In this video, we are going to solve for the kernel and nullity of this given matrix here. This is a matrix which is a 3 by 5 matrix. There are 3 rows and 5 columns. Take note that this is m by n. So this linear transformation that we're going to use here is linear transformation from Rn to Rm. In this case, this is a linear transformation from R5, to R3. Okay, what's the purpose for this? Take note that the kernel is a set of all vectors, okay, that will satisfy this transformation. Transformation of vector v is equal to the product of a and the same vector v equal to the 0 vector. And we're going to solve for all possible values of vector v, okay, in the form of a set, because kernel is a set. The purpose for this is to understand what type of 0 vector we're going to use, on what type of vectors v we're going to solve for. Take note that this is part of the codomain. This is our codomain here. In short, our 0 vector is an element of R3. So you don't need to guess or just simply say whatever 0 vector you would like to use. It should be the 0 vector of this set here. So it's 0, 0, and 0. How about the vector v that we're going to use? It should be the element of domain. And since it's R5, the vector that we're going to use here is an element of R5, meaning v sub 1, v sub 2, v sub 3, v sub 4, and v sub 5. Notice, you don't need, and it's very incorrect to just assume the type of vector and the 0 vector without analyzing this. Well, anyway, the goal here can be seen later, as we are going to use this matrix and the product of this vector, which will be equal to this 0 vector here. But to start, we can actually use here the reduced row echelon form of this matrix. Of course, you can always multiply this matrix with this vector, but it would be very difficult for us to solve for v sub 1, v sub 2 until v sub 5 if we're going to use the same matrix here. So let's come up with the reduced row echelon form. You have negative 1, 3, 2, 1, 4, 2, 3, 5, 0, 0, 2, 1, 2, 1, and then 0 here. What we could do here is first multiply negative 1 to row 1 so that this would be a leading 1. Okay, you could always interchange row 1 and row 2, but since this is not 1 or these are not 1, you're still going to multiply it with a fraction. So just use with this positive 1, negative 3, negative 2, negative 1, negative 4. Okay, the second row and the third row will be the same. Now let's make this 0, 0. Okay, by multiplying negative 2 to row 1 plus row 2 for a new row 2, and the same thing here, plus row 3 for a new row 3. Okay, so this would mean 1, negative 3, negative 2, negative 1, negative 4. So you have negative 2 times 1 is negative 2 plus 2, 0. Oh, 0. Negative 2 times negative 3 is positive 6, plus 3 is positive 9. Negative 2 times negative 2 is positive 4, plus 5, you have 9 as well. Negative 2 times negative 1 is positive 2, so you have here positive 2. Negative 2 times negative 4 is positive 8, so this is positive 8 here. On the third row, you have negative 2 times 1 is negative 2 plus 2, 0 here. Next, negative 2 times negative 3 is positive 6, plus 1, positive 7. Negative 2 times negative 2 is positive 4, plus 2, positive 6. Next, negative 2 plus negative times negative 1 is positive 2, plus 1, 3. Negative 2 times negative 4 is 8, so it's 8 here as well. The next here is to make this a 0 and 3. I mean, leading 1 and 3, so that you would come up with a certain leading 1. So we're going to multiply 1/9 to row 2 for a new row 2. Okay, let's just stick with that method in the meantime. 1, negative 3, negative 2, negative 1, negative 4. You have 0. This is now 1. This is now 1. 2 9s, 8 9s. Okay? 0, 7, 6, 3, and 8 as well. Now let's multiply this row, negative 2, negative 1 to row 2 plus row 3. So this would become 0. So you will have here, okay, so I don't know if the spaces are enough, but let's find out. Negative 1, positive 1, negative 3, negative 2, negative 1, negative 4, 0, 1, 1, 2 ninths, 8 ninths here. Okay, so simply, sorry, this is negative 7, right? And negative 7. Negative 7 times 1 is negative 7 plus 7, 0. Negative 7 times 1 is negative 7 plus 6, so negative 1. Then, negative 7 times this, that's negative 14 ninths. This is actually, in terms of 9, that's 27. So, negative 14, then you have 27, so you have 13 ninths. It's positive, okay? So, negative 14, then that's right. Next, negative 7 times 8 is actually negative 56. In terms of 9, that's 72, right? 9 times 8 is 72. So 72 minus 56, you have 16 ninths. Next, let's make this leading 1. Okay. Now let's multiply negative 1 to our row 3. So this would be a leading 1. So to have a new row 3, hence you will have here, okay, 1, negative 3, negative 2, negative 1, negative 4 as well. So you have 0, 1, 1, 2 ninths, 8 ninths, 0, 0, positive 1, negative 13 ninths, negative 16 ninths. Okay, this is not the row echelon form. To make this a reduced row echelon form, this entry should be 0, this entry should be 0, this entry should be 0, because the leading 1 should have 0, other entries from leading, aside from leading 1, should be zeros on a column. So we could actually add or multiply negative 1 to row 3 plus row 2, so this would be 0, okay? And then multiply 2 to row 3 plus row 1, this would be 0, okay? Take note, we have fractions there, so it would be a challenge here, but let's continue. So this is still 0, 0, 1, negative 13 ninths, negative 16 ninths. So this is 0, 1, so negative, because this is this is 0, right? Negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times 39 is positive 39, plus this, you have 15 ninths. Sorry, that's, let me rewrite it. 15 ninths. Okay? Next, you will have here negative of this with positive 16 ninths, plus this, we have positive 24 over 9. Let's just simplify this later, because we know 15 ninths can be expressed in simplest form as well as 24 ninths. But this may be used as we move further to the next. So let's just continue. Next, for row 1, this is still 1. 2 times 0, this is negative 3. 2 times 1 is positive 2, plus negative 1 is 0. Okay? 2 or twice this is 26 over 9. That's negative. This is also negative 9, right? So negative 9 over 9 is negative 26 over 9. That's at negative 35 ninths. Okay? Next, we will have here 2 twice of this, negative 32 ninths. This is 36 over 9, negative as well. So you have negative 68 over 9. Let me check. Again, let's try to check. Twice of this is 26 plus 9. Oh, that's why negative 35. Twice of this is 32. This is 36 over 9. 32, 36, 68. That's correct. So again, we will just try to simplify the over 9s later, because you still need to remove this by multiplying 3 to row 2 to row 1 to have a new row 1. Of course, if you're going to do that, this would be included in the process, and this would be added something here. So let's just stick with over 9 for us to have an easier computation. So we'll have here 0, 0, 1, negative 13 ninths, negative 16 ninths, 0, 1, 0, 15 ninths, 24 ninths. So this is still 1. 3 times 1 is 3 plus this, that's 0. 3 times this, 0, 0, 0 here. Okay? So as you can see, these 3 rows already come up with the first 3 rows of a reduced row echelon form. But let me continue. 3 times this is 45. Okay? 45. That's positive 45. Plus this, negative 35. So you have 10 ninths. Thrice of this is 72. 72 over 9. This is minus 68. So you have 4 ninths. Okay. So we'll have this now as a reduced row echelon form, or as promised, we can simplify this here. 1, 0, 0, 10 ninths, 4 ninths, and then you will have here 0, 1, 0. This can be 5 thirds. 5 thirds, and then minus, yes, that's 8 thirds. And of course, it is 0, 0, 1, negative 13 ninths, and negative 16 over ninths. Now from here, this one here, already in reduced row echelon form, shall be multiplied, okay, with this vector here. So let me just rewrite it here. Okay, hopefully I could copy this. Okay, so 10 ninths, 4 ninths. Okay, so we'll have here this matrix: 1, 0, 0, 10 ninths, 4 ninths, 0, 1, 0. That was actually earlier. Yeah, 5 thirds and 8 thirds. That's correct. And 0, 0, 1. Okay, here comes the problem. I can't memorize it. Negative 13 ninths and negative 16 ninths. Negative 13 ninths and negative 16 ninths. This will now be multiplied to our vector in R5. V sub 1, V sub 2, V sub 3, V sub 4, V sub 5. Which is equal to our 0 vector in R3. 0, 0, and 0. Okay? So once you multiply this, you will have these equations. The first equation, V sub 1, and then 0, 0, you will have plus 10 ninths of V sub 4, and then you will have plus 4 ninths of V sub 5 equal to 0. Okay? This is 5. Next equation, 0, so that's V sub 2, plus 5 thirds of V sub 4, plus 8 thirds of V sub 5 is equal to 0. Then you will have 0, 0, so V sub 3 plus, or minus, it's minus 13 ninths of V sub 4 minus 16 ninths of V sub 5 equal to 0. So we still have a lot of variables here, but the V sub 4 and V sub 5 have been keep repeating. So let us assign arbitrary variables to them. Let V sub 4 be equal to T, and V sub 5 be equal to S. Oh, this is now our values for V sub 4 and V sub 5. In short, our first equation, V sub 1 plus 10 ninths of V sub 4, that's T, and then plus 4 ninths of V sub 5, that's S. So V sub 1 in terms of T and S is equal to negative 10 ninths of T minus 4 ninths of S. V sub 2 now, plus 5 thirds of V sub 4, which is T, plus 8 thirds of V sub 5, which is S, equal to 0. So V sub 2 in terms of T and S is minus 5 thirds of T, and you will have here, this is still minus 8 thirds of S. Okay. And finally, for our V sub 3, minus 13 ninths of V sub 4, which is T, minus 16 ninths of V sub 5, which is S. So V sub 3 in terms of T and S is positive 13 ninths of T plus 16 ninths of S. Okay, it's very long, right? So, but we're almost there. We're almost done. This would mean that our vector, using this 5 here, our vector V, comprising of V sub 1 until V sub 5, you'll have this form. V sub 1 is negative 10 ninths of T minus 4 ninths of S. Our V sub 2 is minus 5 thirds of T minus 8 thirds of S. Our V sub 3 is positive 13 ninths of T plus 16 ninths of S. Our V sub 4 is T. Our V sub 5 is S. Okay. With these spaces here at the bottom, we can actually separate S and T. You will have here, okay, for our T, you have negative 10/9 of T, negative 5/3 of T, positive 13/9 of T. You have T, and since there's no T on V sub 5, 0. Plus, for our S, negative 4/9 of S, negative 8/3 of S. We have 16/9 of S. We don't have S for V sub 4, so 0, and we have here S. And once we factor T here, you will have negative 10/9, negative 5/3, 13/9, 1 and 0. Okay? Next, you will have here for S plus S, minus 4/9, minus 8/3, 16/9, 0, and then 1. What do we mean by this? This now, let me use this remaining space here. The kernel, okay, of T is a set, declaring that set of T times, you have here minus 10/9, minus 5/3, 13/9, 1 and 0, plus S times negative 4/9, negative 8/3, 16/9, 0 and 1, such that T and S element of the real number. This is our kernel. See, it's a little bit complicated because we have a lot of steps here, but of course, simply follow this one and review this video from time to time, and you will get it right. Then, the nullity of T is the dimension of the basis of your kernel. In this case, you have this and these two vectors here, so the nullity of T is equal to 2. Okay, so this is the kernel, and this nullity of the kernel is the kernel. This is how we do it for this type of matrix, and we still have one more example later. The last video for kernel and nullity, a different form of a matrix. Thank you very much for watching.